In this video, you will learn about decimal equivalents. So what we're learning in particular is you will learn how to express a fraction as a decimal and how to write a decimal as a fraction. So going both ways. So first off, we want to learn how to express a fraction as a decimal. So if you were told to express 5/8 as a decimal, what would you do? Well, remember that fractions mean division. So this means 5 divided by 8. So that's what I do. I take 5 divided by 8. But notice 8 does not go into 5 evenly. 8 is bigger than 5. So what I do is I put a decimal and then a 0 after the 5. And now I see how many times does 8 go into 50. Well, 8 goes 6 times into 50. So I put a 6 up here. And make sure the decimal is lined up with the decimal down here, the 5.0, and the 6 is going to come after that decimal. So here we have 6 on the top, and we multiply 6 times 8 to get 48. So just like normal from here, we subtract to get 2, but then it's not there's a remainder. So what I need to do is add a 0 at the end of the 5.0. So we add another 0, bring that down, now we have 20. And then we see how many times does 8 go into 20. Well, it goes 2 times, so 2 goes up here, and then we multiply 2 times 8 to get 16. And then subtract, we get 4, and it's still a remainder, so I need to add another 0 after the 5, and then bring that down, and then see how many times 8 goes into 40. So 8 goes into 40 5 times. So then I take 5 times 8 to get 40, subtract, and now the remainder is 0. So I am finished. 5/8 can be written as 0.625. Here we have another example. You are told to express 1/6 as a decimal. So remember, the fraction bar means division. So I'm taking 1 divided by 6. Now 6 cannot go into 1 because 6 is smaller than 1. So what I need to do is add a 0 after the 1. So I have 1.0. So 6 goes into 1 0 times, but it goes into 10 1 time. So I put a 1 up here and make sure the decimal is there as well in line with the decimal in the bottom. So 1 goes here, and then at this point we can continue as a normal division problem. We take 1 times 6 to get 6, and then we subtract 10 minus 6 to get 4. Now there's a remainder, so I need to add another 0 after the 1, and then I bring it down to get 40, and then I see how many times does 6 go into 40. And that's going to be 6, so I have 6 up there, and then I multiply. 6 times 6 is 36. I subtract, and I get 4. So this is still a remainder. So I'd have to bring another 0, there, and then drop it down, and then see how many times does 6 go into 40. Well, 6 goes into 40 6 times, and then multiply 6 times 6 to get 36, and then subtract to get 4. Notice this is just going to keep repeating. Then we bring down a 0 again, it's going to be 6 again, and then 36, and then subtract to get 4. This is going to go on forever with a 6. So 1/6 can be written as 0.166666, and it keeps going forever. Now the way we write that repeating part of the decimal is we put a line over top of it. So just put a line over top of the part that is repeating. So it's the 6 that is repeating, so the line goes over the 6. And this is called a repeating decimal. Here is another example where we are told to express 8/11 as a decimal. So the fraction, remember, means division. So I have 8 divided by 11. So 8 divided by 11, looks like this. And then I ask, how many times does 11 go into 8? Well, it doesn't, so that's going to be a 0. All right, but I need to now add a 0 after the 8 to see how many times 11 goes into 80. So 11 goes into 80 7 times, so I put a 7 up here on the top. And the division process from here is the same as normal. We have 7 times 11, which is 77. I subtract to get 3. And then I need to put another 0 at the end of 80 because there's a remainder. So I put another 0, and then I bring down to get 30. And then I see how many times 11 goes into 30. Well, it goes 2 times. So now I have 2 times 11, which is 22. I then subtract to get 8. I need another 0 at the end because there's still a remainder. So I add another 0 and then bring it down. Now I have 80 again down here. And then I see how many times 11 goes into 80, and that's going to be 7 times. So then I take 7 times 11 to get 77, subtract, and I get 3. Now notice that what's happening is things are repeating. We started with 80, and then we had 30. Now we have 80 again, and then we're going to have 30 again once we bring down the 0. And then it's going to be 80, 30, 80, 30. It's going to keep repeating with our numbers. So it's going to keep being 7, 2, then 7, then 2, then 7, then 2. It's going to keep going on forever. So therefore, 8 over 11 is 0.7272, etc. It's going to keep repeating. And because both numbers are repeating, both the 7 and the 2, I can write this as 0.72 and then a line above both of those numbers. So this means that the 7 and 2 will keep going on forever and ever. Next, we have a mixed number, and we are to express this as a decimal. So we have 4 and 5 over 7. So 4 and 5 sevenths. So as a decimal, it'd be helpful if I begin by writing 4 and 5 sevenths as an improper fraction. So 4 and 5 sevenths I can write as an improper fraction by taking 4 times 7, then adding 5. 4 times 7 is 28. 28 plus 5 is 33. So I have 33 over 7. Alright, so I take 33 divided by 7 to determine what this would be as a decimal. So I will need to be adding zeros at the end of this. But I can begin by seeing how many times 7 goes into 33. Well, it goes 4 times, so 4 goes up here. Then I multiply 4 times 7 to get 28. I subtract, I get 5. And then I can bring down the 0 to get 50. So then I ask, how many times does 7 go into 50? Well, it's going to go 7 times. So I have 7 up there. And then I can multiply 7 times 7 to get 49. Then I subtract, I get 1. And then I keep repeating, so I have to bring down another 0. And then I repeat the process. So then how many times does 7 go into 10? Well, it goes 1 time. So I have 1 times 7, which is 7. I then subtract to get 3. There's still a remainder, so I need to keep going. Add another 0 and then bring down. So bring down the 0, we now have 30. And we see how many times does 7 go into 30? Well, it's going to go 4 times. So we have 4 times 7, which is 28. I subtract, I get 2. Still a remainder, so I need to add another 0, bring down to get 20. So then I see how many times does 7 go into 20? And that's going to be 2 times. So then I take 2 times 7 to get 14. Subtract, I get 6. And then I have to add another 0 and then bring down that 0. And then I see how many times 7 goes into 60. That's going to be 8 times. So then I multiply 8 times 7 to get 56. Subtract, and I get 4. There's still a remainder, so I need to add another 0, bring that down, and then I see how many times does 7 go into 40. Well, that's going to be 5 times. So I have 5 times 7, which is 35. I subtract, and now I have 5. So there's still a remainder, so I have to keep going. But notice at this point right here, this is the same as what we had right here. Because at this point now we'd have to drop a 0, and we would repeat with the 50, and then we get all these same numbers again. So what's happening is we have all of this decimal part, the 7142285, that is all repeating. So I can write my number 4 5/7 as a repeating decimal. Okay, so we have 7142285, then repeat 7142285, etc. So the line is going to go above the entire decimal portion, the 7, 1, 4, 2, 8, and 5. So my answer would be 4.714285 repeating. Now there are some common fractions that are just good to know, the conversion to a decimal in your head without needing to calculate every time. So here are a few common fractions that you should have memorized. The first one is 1/2. So 1/2 is the same thing as 0.5. Okay, next we have 1/3 and 2/3. So 1/3 is 0.3 repeating. 2/3 is twice that, which is 0.6 repeating. So we started with the denominator being 2. Here we have the denominator being 3. Next we have the denominators being 4. So we have 1/4 and 3/4. 1/4 is the same thing as 0.25, and then 3/4 is 0.75. All right, and then 2/4 obviously is 1/2, which would be 0.5. Now dealing with the denominator as a 5, we have 1/5, 2/5, 3/5, and 4/5. So 1/5 is 0.2, 2/5 is 0.4, 3/5 is 0.6, 4/5 is 0.8. So basically you're taking the numerator and multiplying by 2 and making it with a decimal in the front. All right, next we have 6. So we have 1/6, and then we have 5/6. 1/6 would be 0.16 repeating, with the 6 repeating, and then 5/6 is 0.83 repeating, where it's just the 3 that is repeating. 2/6 would be 1/3, which we have that over here. 3/6 is 1/2, which we already have over here. 4/6 is the same thing as 2/3, which we already have over here as well. Next we have where the denominator is an 8. So 1/8, 3/8, 5/8, or 7/8. And we should put that one in there as well, 7/8. So these ones, you have 1/8 is 0.125, 3/8 is 0.375, 5/8 is 0.625, and then 7/8 is 0.875. And then dealing with ninths, this one is probably the easiest one. 1/9 is 0.1 repeating, 2/9 is 0.2 repeating, 3/9 is 0.3 repeating, and etc. So whatever your numerator is, that's going to be your decimal, and then just make it repeating. So 7/9 would be 0.7 repeating, for example. And then lastly, we have tenths. So 1/10 is 0.1, 2/10 is 0.2, 3/10 is 0.3, etc. So whatever your numerator is, it's going to be point and then that number. So for example, 8/10 would equal 0.8. All right, so these are just important fractions to know off the top of your head. Okay, next we need to know how to write a fraction, write as a fraction in simplest form. So here we are converting from decimal back to fraction. So let's say we had 0.24. So 0.24, we have tenths place here, and then 4 is the hundredths place. So this can be written as 24 hundredths, or 24 over 100. And then once you have that set up, we can simplify. Here we can divide the top and the bottom by 4, which gives me 6 on the top and 25 on the bottom. Next we have 0.365. So make sure you know your places. 3 is in the tenths place, 6 is hundredth, and 5 is your thousandths place. So this can be expressed as 365 thousandths, or 365 over 1,000. So here I can then simplify, and I can divide the top and the bottom both by 5. When I do that, I have 73 on the top and then 200 on the bottom. And just a quick little trick. So to know how many zeros we need in the denominator, see how many decimal places we have. So here for 0.24, we had 2 numbers after the decimal. So we have 2 zeros after the 1. And then 0.365, there are 3 numbers after the decimal. Here we have 3 zeros after the 1. So just a little trick to help you get set up. Now, what if you had a repeating decimal and you were told to write this as a fraction? So there's a technique that you can use for repeating decimals. So the technique is as follows. You will let n equal your original decimal. So here we're going to let n equal 0.123 repeating. Alright, so n is our variable. And then from here, notice there are 2 digits repeating. Alright, there's a 2 and a 3. So what I'm going to do is multiply both sides by 10 to the second power. So because we have 2 digits repeating, we multiply by 10 to the second power. If there's 3 digits repeating, it would be 10 to the third power, etc. So 10 to the second power is 100, right? 10 times 10. So we can also think of that as, since there are 2 digits repeating, we multiply by 1 with 2 zeros on both sides. So multiply this equation, n equals 0.123 repeating, by 100. So on the left side, I have 100 times n. And on the right side, I move the decimal place over 2 places. So 1, 2. That's going to give me 12.3, and then 2, 3, 2, 3, 2, etc. Alright, so I have 100n equals that, and then n equals the 0.123 repeating. So from here, what I need to do is take both equations, and then I'm going to subtract them. So right here, we're going to subtract these 2 equations. So the bigger one with the 100 minus the smaller one. So on the left side, we have 100n minus 1n, which would give me 99n. On the right side, 12.323, etc., minus 0.12323, etc. This would give me 12.2. And I'll show this over here for you. 12.323, etc., and then 0.12323, etc. When I subtract, notice that here it's going to be 0, 0, 0, 0, 2, and 12 is just 12. So we have 12.20. Alright, so from here, I can solve this equation. So 99 times n equals 12.20. To solve, I can divide both sides by 99. When I divide, on the left side the 99's cancel, and on the right side I have 12.20 divided by 99. So 12.2 divided by 99, we could multiply the top and the bottom by 10 to get rid of that decimal. So that would give me 122 over 990. And then I can reduce this by dividing the top and the bottom by 2. So I divide the top by 2 to get 61, and the bottom by 2 to get 495. So this decimal right here can be written as 61 over 495. Here is another example. We are told to write 0.23 repeating as a fraction. So once again, the process is you begin by writing n equaling 0.23 repeating. Now we see that there is only one decimal repeating, so I'm going to multiply both sides by 10 to the first power. So one digit repeating, 10 to the first power. So we multiply 10 to the first power on both sides, which is the same thing as 10. So on the left side, we have 10 times n. On the right side, multiply by 10 would mean that we move the decimal over one place. So that becomes 2.3 repeating, 2.333. So from here, we're going to take our two equations, 10n equals 2.3 repeating, minus n, which equals 0.233 repeating. So we subtract those two. So on the left side, 10n minus 1n gives me 9n. On the right side, I subtract, and notice that the 3's will cancel, give me 0, 0, 0, and then here 3 minus 2 is 1, and then 2 minus 0 is 2. So this subtracts to become 2.10. So now we just need to solve this new equation. To do that, I need to get rid of the 9, and I do that by dividing. So divide both sides by 9. On the left, the 9's cancel. I have n on the left, and then on the right, I have 2.1 divided by 9. So now I need to write this without that decimal. So instead of 2.1 over 9, I can multiply the top and the bottom by 10 to move that decimal over. So that becomes 21 over 90. And then from here, I can reduce. I can divide the top and the bottom by 3. That's going to give me 7 over 30. So that decimal, 0.23 repeating, can be written as a fraction, and that fraction would be 7 over 30. Now one last thing with decimals, you need to know how to determine if a number is smaller or bigger than another number. So here we see 0.6513, 0.651 repeating, 0.65 repeating, 0.6527, and 0.6610. So it's helpful if you have the same number of decimals, same number of digits after the decimal. So like here, 0.651. If we add another one here, because that's going to be 1 repeating, so 1, 1. Now it has 4 digits, just like this first one. Same thing with 0.65 repeating. We want 4 decimals, so 0.6565. The fourth one already has 4 digits, and then this last one, we can add a 0 at the end. So once you do that, now we can just compare these numbers we have. So we have 6511 is the smallest. So we have 0.651 repeating is the smallest. And then from there, we have 0.6513. That's the next biggest. And then from there is 0.6527. That is the next biggest number. And then after that, we have 6565. That's bigger than 6527. So that's the 0.65 repeating one. And then after that, we have 0.661 as the last one. So it's helpful if you add those extra digits to compare a little more easily. And that concludes our lesson for today. We will see you next time.